Today we are going to start the chapter electricity. Since it is the first lecture on electricity, I am today going to just give a brief introduction of electricity and introduce two key concepts. One is electric charge and second is electric current. First we will see what is the definition of electric charge. Charge is defined as a physical property of matter that causes it to experience a force when kept in an electromagnetic field. So if we have to define the charge, we have to simply say that it is a property of a matter, and by virtue of this property, when a body is put in an electric field, it experiences a force of attraction or a force of repulsion. This property is associated with the matter. This means that electric charge cannot stand or exist on its own. It is simply one of the many properties of matter. For example, a matter has a number of properties. Matter has got the mass, that is a property of matter. In the same way as mass is the property of a matter, electric charge is also a physical property of a matter. What happens because of the mass? Because of the mass, a body is attracted by the gravitational pull of Earth. Similarly, when a body has electric charge, by virtue of that electric charge, when that body is put in the electromagnetic field, it either experiences a force of attraction or a force of repulsion. That is the benchmark to see whether a body has got a charge or not. If you have any body, suppose you have got two bodies, body A and body B. Now we want to check whether body A has got a charge or not. You simply will put this body in an electromagnetic field. If this body experiences a force of attraction or a force of repulsion, then this body has got charge. If suppose a body P, when we put this in an electromagnetic field, it neither experiences a force of attraction nor experiences a force of repulsion, we can simply say that the body B is a neutral body. It does not has any charge. So now this charge is of two types. A body can have the positive charge or a body can have the negative charge. So we can say if a body is a charged body, then we have to see whether it has a positively charged body or it is a negatively charged body. If a body has both positive and negative charge, but the positive charge and negative charge are in equal quantity, then in such a case the positive charge will nullify, it will cancel the negative charge, and overall the body will get the zero charge. Our body, we can say the body is a neutral body. Suppose if we say a body has a 10 units of positive charge and 10 units of negative charge, then this 10 units of positive charge will be cancelled by the 10 units of negative charge, and overall charge of the body will remain zero. So we can say this body is a neutral body. So we can say a neutral body has charge, but it has equal quantity of negative charge and positive charge which cancel each other, and resultant charge or net charge of the body is neutral. So if we see the net charge of an body is equal to 0. Okay, this electric charge is because of the virtue of electrons and protons. Protons have got the positive charge and electrons have got the negative charge. Whenever a body attains the electrons, whenever it gains the electrons, it will become the negatively charged because the electron has negative charge. And whenever a body loses the electrons, it will become positively charged. Okay, so this is a concept of the charge. So you have to just remember that electric charge is simply a physical property by virtue of which it experiences the force of attraction or repulsion when it is put in an electromagnetic field. The charge is of two types. It is positive charge and the negative charge. Positive charge is because of presence of protons and negative charge is because of presence of electrons. And when a body has both equal amount of positive and negative charge, it has overall charge is 0, so it is neutral body. Charge is represented by symbol Q. Symbolically, we represent charge by symbol Q. It is a scalar quantity. Scalar quantity means it doesn't have any direction, it has only magnitude. And mathematically, this charge Q is equal to I into T. So if you have to find the value of Q, you will use this equation Q, that means charge is equal to electric current into time. Okay, so this is the concept of electric charge. Now if we have two bodies, if one body is having a positive charge and another body is having the negative charge, if we put them in the vicinity of each other, these two, because these are dissimilar charges, one charge is positive charge and another is negative charge, they will start attracting each other. A force of attraction will be there. So we have to remember one thing, the unlike charges, that means dissimilar charges, that is positive and negative charge, they attract each other. But if we put the similar charge, that means positive charge and the positive charge, or negative charge and the negative charge in the vicinity of each other, they will repel each other. This is a law of repulsion. So as I said earlier, the charges have a tendency, when they are put in the electromagnetic field, they exert the force. That force can be force of attraction when there are dissimilar charges, or that force can be force of propulsion if there are similar charges. Okay, so you have to just remember now certain key pointers. I will mention certain key pointers here. You just remember these key pointers. One key point is charge is a scalar quantity. Charge is a scalar quantity. The SI unit of charge is coulomb and it is denoted by C. So you have to remember that charge is a scalar quantity and its unit is coulomb. Coulomb is represented by C. As I already said, the charge is of two types, positive charge and the negative charge. I also mentioned that protons have positive charge while electrons carry negative charge. We also mentioned that if we put the two unlike charges in the vicinity of each other, they will exert a force of attraction. Unlike charges exert a force of attraction. But if we put the two similar charges, that is positive, negative and negative, or positive and positive in the vicinity of each other, they will repel each other. We also mentioned that charge is denoted by symbol Q and is mathematically represented as this Q is equal to charge is equal to I into T. That means if you have to find the value of Q, that is value of charge, you can simply write that Q is equal to product of electric current and time. A conductor gains negative charge if electrons are added to it. If you have any matter, and you want to add electrons to it, it will gain, because electron is negative charge, has got negative charge, so they will make the conductor a negative charged body. But if it loses electrons, if it gives out the electrons, if it loses the electrons, then it will attain the positive charge. So here I have, if it while it attains, you have to write positive charge. It is wrong here. A conductor gains negative charge if electrons are added to it. If it loses electrons, then it will gain the positive charge. However, if both positive charge and negative charge, that means electrons and protons, are present in the body in equal quantity, in equal number, then the body will be neutral. It will have zero charge, because positive charge and negative charge will cancel, nullify each other, so the resultant charge will be, net charge will be negative, will be zero. So these are the key pointers here. Charge is a scalar quantity. SI unit of charge is coulomb. Charge is of two types, positive and negative. Like charges repel each other, unlike charges attract each other. Charge is denoted by symbol Q, and mathematically you can write Q is equal to product of current and time. Conductor gains negative charge if electrons are added to it, while it gains a positive charge if it loses electrons. If it has both number of positive and negative charge, it will be neutral. This is the concept of charge.